Hello everyone. In today's lesson, we are going to continue talking about division with fractions. And today we're going to look at how we can divide a fraction by a whole number. Our objective is to be able to use a model to divide a fraction by a whole number and use the algorithm for dividing fractions. So in this video lesson, you'll actually learn two different strategies. You'll learn how to use a model to divide a fraction by a whole, and you'll get your first look at the algorithm that's used for dividing fractions. For your to-do list today, the first thing is you need to complete this video lesson and make sure to answer all questions throughout the video. Then you'll have to finish the set of boom cards that are posted on Google Classroom. You need to make sure that you complete all of those cards, so the entire deck. And then finally, you'll finish your math block by working on your fraction boot camp. Before we move on, let's just talk about the vocab. Today we'll talk about models, the algorithm, and we'll learn what the word reciprocal means. All right, so let's get into our mini lesson. Today we're looking at how to divide a fraction by a whole number. Let's start by using a model to divide a fraction by a whole. In this example, I have 2/5 divided by 3 equals x, and I want to solve for x. So I'm going to use a model and start by modeling 2/5. So I'm going to create a whole, split it into fifths, and then color in 2 of them. Now I want to split the 2/5 that I have shown into thirds. To do this, I'm going to draw horizontal lines to split this whole in the fifth into thirds. Now I'm going to find my new denominator, which would be the total number of units that I've now split this whole into. So in this example, I have a 5 by 3 grid, which means the denominator will be 15 because there's 15 whole units. Now, to find my numerator, I just need to look at how many shaded their units are in each of the thirds. So I'm going to circle the top third because I want to just figure out how many 2/5 will be in each of the thirds. So I'll just count those shaded sections and I'll get 2 for the numerator. So that means that 2/5 divided by 3 is going to be equal to 2/15. Let's look at another example. This time I have a word problem. It says, Tiffany has 4/7 of a brownie pan left at the end of a party. She wants to give the remaining brownies to her 5 guests. How much of the brownie pan will each of her guests get? To solve this problem, I'm going to use the equation 4/7 divided by 5 equals g for the amount each guest will get at the end. Now I'm going to use a model to solve. So first, I'm going to model 4/7 by splitting a whole into 7 parts and then shading in 4. Now, you can imagine this is the 4/5 of the brownie pan that's left, and Tiffany wants to split it among her 5 friends. So I'm going to divide the 4/7 that I have into fifths horizontally. Now, to see how much each of these little sections is, I'm going to find my new denominator, which means, in this case, I'll find 7 by 5. So the denominator will be 35ths, which means each of these little rectangles is equal to 1/35. Now I want to find out how much each of her friends gets. So I'm just going to look at one of the fifths that I've separated and count those out. And I see that each friend will end up getting 4/35. So you can imagine, like, this is friend 1 gets 4/35, friend 2 gets 4/35, friend 3 gets 4/35, and so on. All right, now it's your turn to do some practice. You're given 2 models here, and only one of them is correct for the equation 3/4 divided by 2 equals y. Go ahead and select model A if you think that's the correct model for this equation, or select model B if you think that is the correct model. So for this example, model B would be the correct model. That's because I have started with 3/4 vertically, and then I split it into halves or 2 parts horizontally, and then counted the parts in just the top half. So that would be 3/8 total. Now go ahead and tell me what is incorrect about model A. You could have worded this a number of different ways, but the error in this model is that this model represents 3/4 divided by 3 because it's now separated into 3/4 vertically, and then there's 3 parts horizontally. So this model is incorrect because it divided by the wrong number. Let's do another example. Go ahead and tell me which model correctly represents the following equation. 5/6 divided by 4 equals z. Is model A correct or model B? For this particular equation, model A is the correct model. I want you to go ahead and now tell me why is model B incorrect for 5/6 divided by 4 equals z. You could have worded this a couple of different ways, but if you said something similar to this model is incorrect because only 4/6 is shaded, there should have been another column or another vertical section shaded. So this model actually represents 4/6 divided by 4, not 5/6 divided by 4. All right, now that we've looked at the models, let's start talking about the algorithm. An algorithm is a mathematical process that can be used to solve different types of equations. So there are a whole bunch of mathematical algorithms, and you already know some of them, like the long division process. That's an algorithm that has steps that are broken down, and you can follow that to solve those types of equations. Today, we're going to look at the algorithm for dividing fractions, which is actually pretty simple and only has 2 steps. So let's look at those steps. Number 1 is you multiply the dividend by the reciprocal of the divisor. I'm going to read that one more time. The first step is you multiply the dividend by the reciprocal of the divisor. We'll talk more about what that looks like, but the second step is just to simplify. So really, the major thing you have to do in dividing fractions is you multiply the dividend by the reciprocal of the divisor. Now, that's a lot of academic language, so let's break it down. Dividend and divisor are terms for the parts of a division problem. So if we have a division problem, it's represented by a dividend divided by the divisor and is equal to a quotient. So the dividend is whatever number you're starting with, and you're breaking into equal groups. The divisor is then the number that you're dividing by, or the amount in each group. And then the quotient is the answer. So in this case, or in the algorithm for fractions, we need to focus on this dividend and the divisor. Now, let's talk about this word reciprocal. A reciprocal is the inverse or the opposite of a fraction. To find the reciprocal, you simply flip the fraction. So let's look at an example. If I have the fraction 1/8, the reciprocal of 1/8 would just be the inverse or the opposite of that fraction, which means I just need to flip the numbers. So the reciprocal of 1/8 would be 8 over 1. Another example is if we have the fraction 2 over 3, or 2/3, the reciprocal would then be 3 over 2, or 3/2. And these reciprocals end up being the inverse of the original fraction. We can test this out because if we multiply a number by its reciprocal, it should cancel out. So if I do 1/8 times 8 over 1, I would get 8 over 8, which equals 1. So I know that these are inverse fractions because they end up canceling each other out, and I just get a product of 1. Same will work for 2/3 and 3/2. These are reciprocals, so they're the inverse, and if I multiply them, I would get 6 over 6, which is again equal to 1. So reciprocal fractions end up canceling each other out, and we can use reciprocals to make the division of fractions a lot easier. So let's now look at this process with a model and the algorithm. Here I have 2 divided by 1/4. I could model this by drawing 2 holes that I would split into fourths, and then I would just need to count the number of fourths that I now have. So in this case, I have 8/4, which means 2 divided by 1/4 will give me 8. Now let's try the algorithm. I'm going to multiply the dividend by the reciprocal of the divisor. First, I have 2 divided by 1/4. I'm going to go ahead and make 2 into a fraction. So if I have 2 wholes, that would be 2 over 1. Now, 2 over 1 will be my dividend, and 1 over 4 will be the divisor. So I need to find the reciprocal of my divisor. The reciprocal of 1/4 would just be that fraction flipped, so it would be 4 over 1. So then I would rewrite my equation as 2 times 1, which is my original dividend, times the reciprocal of my divisor, so 4 over 1. And when I multiply straight across, 2 times 4 will give me 8, and 1 times 1 will be 1. 8 over 1 is equal to 8. So we can see that whether you choose to model your fractions or use the algorithm, we still will get the same answer. Let's look at another example. This time I have 7/8, and I'm dividing it by 3. So I could draw a model of 7/8 and then split it into 3 groups. Do that horizontally. And then I would just need to figure out my new denominator, which in this case would be 24 because it's a 8 by 3 model. And then I'll just need to count the number of shaded 24ths that I have in each group that I separated it into. So in this case, there are 7. So that means that 7/8 divided by 3 will give me 7/24. Now let's test out the algorithm. Again, I'm going to multiply the dividend by the reciprocal of the divisor. So that means I have 7/8 divided by 3 equals z. And again, I'm going to make my 3 into a fraction by putting it over 1. So now I can see my dividend is 7/8 and the divisor is 3 wholes, or 3 over 1. So to follow the algorithm, I need to figure out the reciprocal of the divisor. So the reciprocal of 3 over 1 would then be 1 over 3. So I'm going to rewrite my equation as the dividend, 7/8, multiplied by the reciprocal of the divisor, which we said is 1/3. Now I just need to multiply straight across. 7 times 1 would be 7, and 8 times 3 would give me 24. So again, I get 7/24. Now, one way that you can easily remember this algorithm is with these 3 simple steps: keep, change, flip. And this means you keep the first fraction, you change the operation to multiplication, and you flip the second fraction. So let's look at a couple examples. If I want to solve 5/6 divided by 3, or 3 over 1, I'm going to keep my first fraction as 5/6. I'm going to change the operation to multiplication, and then I'm going to flip the second fraction. So I just use keep, change, flip, and now I just need to do the multiplication. 5 times 1 is 5, 6 times 3 is 18, so I would get a final answer of 5/18. Let's look at another example. This time I want to figure out what is 3 wholes, or 3 over 1, divided by 1/4. I'm going to keep my first fraction, change the operation to multiplication, and then flip the second fraction. So now my equation becomes 3 over 1 times 4 over 1, which is just 3 times 4, or 12, as my final answer. All right, you probably know what's coming. It's your turn to practice. Go ahead and use the keep, change, flip method to divide these two fractions. All right, let's check your work. For the first one, 1/2 divided by 4 over 1. To use keep, change, flip, I would keep 1/2, change the operation to multiplication, and then flip the second fraction to 1/4. And then I'll get my final answer of 1/8. So 1/2 divided by 4 would give us 1/8 pieces. Next, if we have 6 over 1 divided by 1 over 3, or 6 wholes divided by 1/3, we could keep the first fraction, change the operation to multiplication, flip the second fraction, and then we would just multiply straight across. 6 times 3 is 18. Over 1 is the same as just 18. So there we get our final answer. All right, that is the end of our lesson.